So the last lesson of the unit that you are going to review today is using absolute value inequalities. When we look at our cases, we have two cases, case 1 and case 2. This looks like absolute value equations, and we're going to do the same thing where we're going to solve two equations. When I look at my first one, we have a greater than sign. Greater than or equal to. What that means is this is going to be an or inequality. Greater than. Okay, so when I go to graph this equation, I would go and I put x is greater than or equal to 5, or x, and this is where the magic happens. We go less than or equal to, and we have to change the sign, -5. So we're flipping the sign, and we are taking the opposite of the sign. Okay, so then when I go to graph it, it'd be greater than 5, equal to, we go to the right, less than or equal to -5, go to the left, so negative infinity to -5, and 5 to infinity. Okay, now we take a look at the next one. This is less than. See this and part? These will always be and inequalities. Again, we're going to do another compound. So I'm going to put x is less than or equal to 8. Then my other one, I'm going to do x, flip the sign, greater than or equal to -8. So when I go to graph, we have -8. X is going to be greater than, so we're going to shade this way. 8. X is going to be less than, so we're going to shade this way. So it is an and statement. We write it in interval notation. We're going to put -8, comma 8. So again, we want to remember that absolute value inequalities are really compound inequalities Okay, so less than, remember, is going to be your and. Greater is going to be your or. So really say it like that in your head and exaggerate it. So our first step, of course, is still isolating the variable. Create two cases. We don't use this KISS method. Okay, but we just want to set up the two cases. Number 2, solve and graph. Okay, so let's do number 1. Again, we're going to do x is less than 7. And it's and, right, because it's less than. So and x is greater than, I'm flipping the sign and putting a negative. So less than 7. Greater than -7. So we shade in between. Interval, we're going to go -7 to 7. Okay, pause the video and do number 4. And type in your answer. Okay, then we have number 3. This is an or, right? X minus 1 is greater than 6, or x minus 1 is less than -6. You cannot forget to flip the sign and take the opposite of your number. So I'm going to add 1, x is greater than 7, or x is less than, add 1, -5. So I'm going to circle -5. X is less than, and then we have 7, x is greater than. So that's going to be a combination negative infinity to -5 and 7 to infinity. Okay, you do number 4, and you'll type in your answer. Number 5, 2x plus 5 is greater than or equal to 3. And again, it's greater, so or 2x plus 5 is less than or equal to negative 3. Remember, every time I'm switching the sign and taking the opposite. So then I'm going to go and solve, and it's greater, so that's why I know it's or. 2x is greater than or equal to negative 2. X is greater than or equal to negative 1. 2x is less than or equal to negative 8. X is less than or equal to negative 4. So we have negative 1, which we shade to the right, which is greater than, and equal to is just shade in the dot. Negative 4. Hey, I'm recording a video. Can you go somewhere else, please? And then it's less than or equal to here, so we're going to shade to the left. And when we write that in interval notation, negative infinity to negative 4, no bracket on this one. We do parenthesis, bracket, and negative 1 to infinity. Okay, we'll do 6 together. First step, we isolate, so we add 1. So we get x plus 3 less than 5. And remember, this is less than. There's that and. So I'm going to go x plus 3 is less than 5, and x plus 3 is greater than negative 5. And we solve, x is less than 2, and x is greater than negative 2. So greater than negative 2, less than 2, we shade in between. So we get our parentheses, negative 2 to 2. Remember to put it from smallest to largest or it's wrong. Number 7, first step, divide by 3. Divide by 3. So I'm going to get 2x plus 8 is greater than or equal to 10. And remember, this means greater. So since it is greater than, it's going to be an or statement. So or 2x plus 8 is less than or equal to negative 10. So 2x is greater than or equal to 2. X is greater than or equal to 1. 2x is less than or equal to negative 18. X is less than or equal to negative 9. So negative 9 less than or equal to 1 greater than or equal to. And again, we're going to get negative infinity to negative 9 bracket and 1 bracket to infinity. All right, let's do 8 together. First step, we times it by a negative 2. We times this by a negative 2. When I do that, we get 4x minus 8 is now greater than or equal to 12. Two equations, 4x minus 8 is greater than or equal to 12. 4x minus 8 is less than or equal to negative 12. I get 4x is greater than or equal to 20, and x is greater than or equal to 5. Here we add the 8. Add the 8. 4x is less than or equal to negative 4. X is less than or equal to negative 1. Now remember, because when we isolated the absolute value, that flipped this, right? So it started out as an and, but once we isolated it, it became an or, which is why we're split like this. So I go negative 1 less than or equal to, and 5 greater than or equal to. So again, we're going to go ahead and graph it. I write in an interval notation, negative infinity to negative 4 equal to. and then 5 to infinity. Okay, do number 9 on your own. You'll type in your answer. And now we'll do the last one together. So I'm going to minus 11 half 4x minus 4 is less than or equal to 4 times 2 times 2. 4x minus 4 is less than or equal to 8. 4x minus 4 is greater than or equal to negative 8. Add 4x is less than or equal to 12. X is less than or equal to 3. Add 4x is greater than or equal to negative 4. X is greater than or equal to negative 1. So when we go to solve, negative 1, circle, shade, 3, circle, shade, it's in between. So I'm going to graph this as negative 1 to 3, end of bracket.